Good afternoon. Welcome to Spring Working Group. So we have a full agenda, so we're about to start. If someone could close the door. So good afternoon. Rob could not make it, so I'm the only one. This is the agenda for today. As always, we have a full agenda. So please, if you're present, keep your allocated time. And if you have comments, please make short comments and do not repeat the points that have already been made. We don't have a share slides, so not well. We'll assume you have already read them. We do need a scribe. Any volunteer for scribing? Especially that some people did not make it to Singapore. Any volunteer for the scribe relay? Please. It may be short. No volunteer? Robin? Could you help with being the scribe, please? To relay the scribe, or do you don't have a laptop? So okay, so we'll do without the scribe, Jabber scribe. So this is the agenda. Again, full agenda. Any comments on the agenda? Thank you. Thank you, Robin. Okay, so we'll proceed. So the first speaker is Shradha. Shradha. Okay, so we'll skip to SR applications so far.
Hello.
If you want.
Okay, thank you. My name is Zafar. I am going to present this replication segment draft on behalf of the authors. Unfortunately, Dan and Rishab and Jeffrey cannot make it, so I'm just helping with the presentation. In terms of brief history of this draft, so work actually started back in 2018, and it was named as Draft Voyer SRP20 policy. It was presented by Dan Voyer in Prague, IETF, and it did receive comments from chair as well as from working group. And based on those comments, the way those comments are addressed is by splitting this document into two. One document talks about replication segment. So the scope and discussion today is on replication segments, where Spring itself has the expertise. And then how these replication segments are used are, the expertise are with the multicast working groups. So that document is in the PIM. There has been lately quite a few comments on the mailing list. Many thanks for those comments. Authors have addressed those comments and have done a revision during this week and has also calls with the people that have comments, especially Shasha. Many thanks, Shasha, if you are attending for your comments. We have made tremendous progress in terms of achieving a common ground and addressing comments. And if there's a need, there could be another revision really quickly. Let's talk about the scope of the draft. This draft is specially targeting an Spring Charter item. And I read verbatim. Spring is Charter to define new type of segments mapping to forwarding behavior. And then one of the definition of those is local English replication. The draft is no more than local English replication. Replication segments deliver packets to multiple nodes in the SR domain, but it's a direct replication from ingress to the set of downstream egress nodes. A copy of the packet is unicasted to each of the downstream node. In way you can think of it is a simple replication segment with local replication over n SR policies. But the point to note is that in this case, there is no multicast groups in the context of the document or scale of the document. There are no multicast flows that we talk about. There's no receiver join. There's no tree building. All of these things are outside the scope of this draft and topic for discussion with the working group where multicast expertise exists. Here, we are working specifically to fill and address a chartered item for Spring. What is replication SID, which is what has been defined here? This is a forwarding construct. It identifies segment in the data plane by an MPLS label or SRv6 SID. This is more like binding SID. And when a packet comes with that SID, then it gets replicated to each of the egresses using the unicast. So then it perfectly maps to 8402 in terms of when the packets are replicated via local policy is a push operation as per SR architecture 8402. When active segment is the replication ID, then it's a simple continue operation. And at the downstream node is a simple next operation. In terms of replication segment, as we discussed, is a local segment instantiated on a single node in the network, which is, you can think of it ahead. And then it performs replication over a set of SR policies. The SR policies could be just best effort route, which means that it basically is a best effort unicast using the prefix SID of the downstream node that are part of the set, replication set. Or it could be the SR policy, which steer the traffic through some traffic engineering path to that set of downstream node unicast fashion. And is identified by the replication ID and the node ID, where node ID is the ID of the node where replication segment is instantiated. There are multiple implementation of this draft that are available, and at least one deployment is known and planned. And that for that implementation, the code is in Bell Canada lab for trial for deployment. We would like to get this simple document adopted as per the charter item. And would like to solicit any feedback, comments. My colleague is also online, Rishab.
Any comment? So the goal of the draft is to have is to define a local replication scheme called segment replication, We've discussed with the chair of PIM working group, and they had some presentation related to doing some multicast in Spring networks. And so if you're interested in that, you can also go to PIM, and they are likely to start some discussion on the adoption.
Wim Hendricks from Nokia. I think this is a good idea. So we should, I support this work because I think it's very useful and a very easy way to support multicast with segment routing.
Thank you, Wim.
So you like to get a pulse for the room in terms of support?
We'll ask on the list. We'll start an adoption poll on the list next week.
Okay. But in reality, like PIM's work is different and would be proceed independently.
PIM's work is different. It is just for information. We have discussed with the chair of
Okay,
PIM.
thank you.
Yeah. Himanshu from Siena. I also want to support this draft. This is a really good replication, ingress replication stuff. So pretty straightforward.
Okay.
Thank you.
Thank you. Shara, do you want to present your draft?
Good afternoon, everyone. So this is a draft on how to use BGPLS EPE for inter-AS purposes. So on behalf of co-authors, I'm presenting this draft. This draft was presented in IDR in Prague, and we got a feedback that we should present it in Spring as well.
Can you start clicking?
So this draft is regarding BGPLS extensions for BGP EPE and using that advertisements for inter-AS traffic engineering purposes for SR networks. So there are some gaps in being able to use BGPLS EPE for inter-AS traffic engineering purposes. So let's see what are the problems. So this is for a deployment use case where it's a single administrative domain, but deployed in two different ASs. So we have this protection mechanism for EPE SID. So you could, if you have an adjacency, peer adjacency SID, you could define another adjacency SID as a backup for this, so that when this link goes down, you can use that other adjacency SID as your traffic will flow on the other adjacency SID. So imagine a controller which is doing traffic engineering and coming up with which SID should be used for which kind of traffic. It really doesn't know which, when it fails, where the traffic is going to go and whether that has enough bandwidth or not. So to be able to do that, controller is going to learn the EPE SIDs from the ASBRs. So it can also learn which SID is being used as backup for which other SID. So we define this F bit in the existing flags, and this FRR SID will be included as part of the peer adjacency SID advertisement, just how you would include a peer set SID. But for peer set SID, the F flag would not be set, whereas for a SID which is getting included as to indicate that it's being used as backup, the F bit will be set. That's what the idea is. So second problem. So this is regarding.
Hey, Sunil. So in this context, the F bit stands for FRR. Is that
Yes,
right? Okay.
Yes. So second problem is peer node SID. So this is a case where there is an eBGP multi-hop session between the two ASs, between R1 and R2, which are the ASBRs. And we have a peer node seed advertisement for this eBGP multi-hop peering session, and traffic is expected to load balance between these two links shown here. So as part of peer node seed advertisement, what we get is the BGP multi-hop session local addresses, which is R1 and R2's loopback addresses. So the controller doesn't really know which are the actual links that are being used for this node SID. So a controller that is doing traffic engineering and doing bandwidth management, it can't really know what are the links and what are the associated bandwidth with respect to those links. So the proposal is, so when you advertise a peer node SID and when you want to do traffic engineering and bandwidth management over these, peer adjacency SID is a must for each of those links. So peer node SID can be used for load balancing, like you have one SID and you can load balance your traffic across the two links. But you should separately also advertise peer adjacency SID and associate all the traffic engineering attributes to that adjacency SID. So this draft mandates the peer adjacencies, advertisement of peer adjacency SID, even though you advertise peer node SID. And one more property is you should also advertise as an attribute in peer node SID the link addresses. So there's a new TLV defined, which is the link address TLV. It carries the interface addresses of the links which are corresponding to the peer node SID. So the TLV looks like this. It has type, length, and number of IPv4 interface address pairs and number of IPv6 interface addresses, and the actual pair of interface addresses. So when both, so this is a case where some interfaces are IPv4 and some underlying interfaces are IPv4 and some underlying interfaces are IPv6. In that case, the IPv4 addresses are encoded first, followed by the IPv6 addresses. So the controller is responsible for looking at peer node SID and these attributes and correlate which peer adjacency SIDs these peer node SID corresponds to, and get the traffic engineering attributes such as bandwidth and other color, link color, or other traffic engineering attributes from this advertisement. So this advertisement is mainly used for correlation by the controller. That's the summary. It strengthens the inter-AS SRTE in this particular mentioned scenario. So we request review and comments.
Oh, hello. Adrian from Thai Telecom. You know, for the inter-AS topology scenario, we also have some proposal in our there. Here I just want to ask you one question. If you based on the EPE to build the inter-AS topology, so if we have several bound router SBR between different AS, so does it need the every SBR to run the BGP protocol?
Yeah, that's right. Yes.
I think this may be some deployment restriction, you know, because in our network there are almost every edge router all connected with our main network. So if we based on the EPE solution, then every edge router must run the BGP protocol. I think this is maybe some extensibility issue.
Yeah, so but for EPE purposes, you anyway have to run BGP LS EPE, and this mechanism is just reusing that to build inter-AS paths across the two cooperating domains. Thank you.
Thank you, Shadra. Any more comments? So next one is Rakesh from 40 WAMP.
Good afternoon, everyone. My name is Rakesh Gandhi, and presenting this SRPM drafts using TWAMP Lite on behalf of the authors and contributors. Sorry, I do have a cold, so is it better? Oh, thank you. So there were two other drafts as well. The one 6374 MPLS SR and MPLS IOAM. So both drafts are now moved to the MPLS working group. So they were on agenda, but we won't be presenting them. They were presented Monday in the MPLS working group. So the agenda is requirements and scope, the history of this draft, the updates we have made since IETF in Prague, based on many review comments and suggestions, the summary and the next steps. So the requirements is delay and loss measurement for links as well as end-to-end SR policies, both SR MPLS as well as SRv6 data planes. No need to bootstrap the PM sessions. I think this means no negotiation, no signaling. That's the spirit of SR. It is stateless on egress node. Again, goes with the SR simplicity. We need to handle the ECMP for SR policies, support direct mode loss measurement as well. So the scope is using the RFC 5357 TWAMP Lite probe messages. We have now also included the stamp. Stamp is was approved by IESG, so it should become an RFC soon. It's a fixed length version of TWAMP Lite, and basically using the user configure UDP ports. So the history of this draft, it was first published in February this year, but it is based on the UDP PM draft that we had published the year before. So uses it's just an evaluation of the UDP PM draft. So it's been around for some time now. This was presented in Prague in Spring Working Group, and then it was also presented in IPPM Working Group in Montreal. So based on the review comments, suggestions, many thanks to everyone who contributed. We have updated the drafts. We welcome Mac as well as Bart as co-authors. We have added the provisioning model that useful for this solution. Now also include the stamp message formats. Also define the loopback measurement modes. We have added the TLV for two-way measurement mode. We have clarified and added the message processing rules for TTL, router alert option, and UDP checksum. Also elaborated procedure for P2MP SR policy. There is some format alignments between loss and delay measurement as well, and some editorial changes. So just to give a summary of the changes that we have made since this was presented last time. So this is a provisioning model, basically both the sender and responder provision for the delay or loss and the corresponding UDP port, timestamp format, PTP or NTP, along with protocols. It could be TWAMP Lite or stamp and whatnot, authentication key and mode. So it now defines the measurement modes. So one way is that reply is sent out of band on IPUDP path. Two-way measurement mode, reply is sent using the return path TLV that's received in the query message. And in the loopback measurement mode, the probe query message contain the return path in the header of the packet. So basically packets are not punted on the responder side. So this is the return path TLV defined. This is carried in the TWAMP or a stamp query messages. It defines various types for SR-MPLS as well as SRv6, including the corresponding binding seats as well. So this is the message format defined for direct mode loss measurement. So they have fixed, the main characteristic is that it's a fixed length and they have fixed location for their counters. So it makes it hardware friendly. And it's aligned with the DM message format as well. So if hardware knows where to put timestamp, hardware will also know where to put the counter. We have also defined them for authenticated mode. And this is basically using a different UDP port that's user configured for loss. And the one in purple is basically for stamp, is a fixed format, so the padding is not required. So next steps, we welcome your comments and suggestions. This has been implemented and deployed. We presented this draft in IPPM, and they asked us to keep them in the loop about the milestones. We do believe that the draft is ready for working group adoption in spring. Thanks. Any comments, questions?
So who has read the draft? About 10-15%. Among the person who has read the draft, we believe it's ready for adoption. About the same. And any person believe it's not ready for adoption? Okay, nobody. So I'll discuss with Rob. We have, as you have noticed, we have a few backlogs, draft of backlog for adoption. We are working to advertise that on a public web page so that it's more it's clarified with everyone. But we'll consider that definitely there is support in the room, and we'll need to confirm on the list.
Okay, thank you.
Thank you. So next is Zafar.
Thank you. Thanks, Bruno. So this is a document that we presented last time in Spring Working Group and at this IETF as well in Spring Working. Sorry, last time in MPLS Working Group and this time as well as in MPLS Working Group. Is certainly something that we're looking at the chairs in terms of the home for this work. The document talks about generic FEC TLVs for LSP ping, and I'm presenting on behalf of my co-authors. So problem statement goes as follows. In MPLS, for ONM purposes, for ping and trace route, we define a FEC stack sub TLV. And to date, every time we define a new SID type, we have to go and define a new FEC stack TLV and define procedure associated with it. The way that the ONM protocols are defined, then it requires a software upgrade depending on the type of the segment ID that is deployed. And then it also raises scaling issues with respect to the amount of information that are needed to properly fill the FEC sub TLV. This is not to pick a specific example, but this is some of the FEC types that are in queue. Basically the point to show here is the amount of information that goes for ONM purposes is large. Part of it is because the way that MPLS ONM is designed is to always do data plane versus control plane validation. And to carry the entire information for the control plane is where the complexity and the amount of information that is required to filling comes. It is a complexity from the point of view of ingress node, being able to gather this information and then carry in the packet for probe, for O&M probe. And it's also has complexity for the egress, because then egress has to validate a lot more information, read that information, gather that information, do a lot more processing against that information. So, and then we talked about that this becomes a case where for every SID type, we have to define a new fact type, which in reality, we have defined SID type for which O&M fact type has not been defined yet. And that is causing problem with in deployments. So in deployments, a lot of time, the basic one type of fact that always works is nil fact. But it has no validation at all, for no egress validation. But it is consistent that no matter what SID type you have, the nil fact work. Now, that is the motivation behind, and then from that as the motivation, we started to see that, okay, maybe we look at the SR SID data model, and based on the data model define one fact that consistent with the data model, and we focus on data plane validation and leave the data plane to control plane consistency checking to a local procedure at the node. Every node has procedures to locally check its own data plane with control plane. No remote node has to tell them, oh, by the way, can you check this? This is a local matter. So that also leads to simplification, and that is the main motivation here. Segment routing is all about simplifying the operation, and I think O&M is not really simplifying, but it is because of the history of control data plane validation, we have complexity still. So from a FED, so once we take that SR data model, base data model, and then we define some procedures, so that would lead to procedure that would be based on local, at the egress side, based on the local implementation, maintaining a SID ID to interface mapping by any node. And initiator would just put in the data field that are required, like which is the segment, who's the segment initiator. And it can also, in many cases, if you can fill the endpoint address, that could be used directly for validation as well, and it simplifies much more and also covers binding segment or pinging a binding segment. So we included that as well. So generic fact is, label fact is nothing but what is the SR SID and who has assigned it, and optionally adding the endpoint address. And SID obviously is the label, the 20-bit label, and the assigner is the node ID of that assigner that has assigned it. And LSP endpoint may be set to 0 when the initiator doesn't know who would be the endpoint, but may be set to the endpoint, let's say binding SID. If the ping is for the binding SID, then endpoint is known. However, if ping is to a parallel agency, then the endpoint is not known. So depending on the circumstances, the endpoint is optional. So let's go over this in some cases that do not work today and how it will work with this fact type. So here we say that 16000X is the prefix SID associated with algo 0, and the example here is using the same fact to address ping or trace to a prefix SID for algo 128 or any other algo. Today we don't have this procedure. Today we don't have this coverage. But the way it will work here is that the initiator 1 will carry the fact. So let's say, take one example at a time. So we want to send to ping prefix SID with algo 0, then the initiator will carry the prefix SID 16008. The assigner is R8 and the LSP endpoint is R8. When the packet comes to node 8 knows that it can receive this packet either on link 1 or link 2. It is the endpoint, it's a very simple case, and node 8 can send the response positive or negative accordingly. Now, the same procedure would apply for flex algo based prefix SID labels. So that's a 16128.8 with LSP endpoint 8 and the assigner R8 will work exactly the same way as flex algo. So we can have coverage across the flex algo without having to define a new set type or extending the flex algo ID in the existing FEC. So if we think with the parallel agency SID, the parallel agency SID case today is not covered by RFC because the initiator 1 does not know which interface the parallel agency will hash to. So it is a local matter as 7. So initiator from 1 would not know, so hence it put 000 as the target value for the interface where it would be receiving the packet. Here is with this FAC type, it will be easy because what will be carried in the FAC is the SID, which is the agency SID, and then in this case parallel agency SID 9378, and the assigner, which is R7, and the LSP endpoint in this case could be R8, but it could be 000. Now, regardless of where the packet will go to, when the packet comes to 8 has a local table that basically say that, this is not my local label, but I received it from my neighbor. Is the assigner my upstream neighbor? Yes. Does this label belongs to the upstream neighbor agency SID on the interface I receive the packet? Yes. So it's good. Otherwise, it fails it. Now, this is an improvement from the current condition because in current condition, because they put the link ID to be 000, 8 can receive the packet from any other neighbor and will still think that it has reached from the right neighbor and the validation will still pass. So this is strict compared to that. And then same thing will work in the case when you have parallel agency to different neighbor. In this case, parallel agency to neighbor 8 or neighbor 88. And the agency SID associated with it 9778. 7 will do hashing based on whatever load balancing parameter packet carries. Packet may end at 8 or 88. There is no endpoint specified 000. But when the packet received either by 8 or 88, it can locally verify that yes, this label is assigned by R7, and yes, the interface on which I receive the packet correspond to this agency SID assigned by the R7, and it can respond accordingly. So, like I said, that this requires 8 to carry this mapping table, and main thing, just to recap, is that motivation here is to really go and simplify fact type for O&M operation for segment routing with this, and then in such a way that we can cover all different SID types that are today or in future, and we can extend this we can easily support it once, and then we don't have to do software upgrade to define new fact type, etc. Please.
Sam Aldrin.
Sam.
Two questions. If the target FEC is any acid, what is the procedure like you're going to use to validate?
So come one more time.
If it is any cast,
If
is any cast,
yes,
how exactly you're going to validate the?
so the anycast.
What is the recommendation for the?
So anycast can go with the endpoint because you would know. No, anycast said. Hold on a second. So you have, I think what we, Ketan, you have come?
We can take it offline. Or
Yeah.
Sure, we can take it.
We can take it offline, but I actually have
So
one question.
Anycast is also prefix SID, so it will be anycast prefix. The endpoint would be the anycast IP address. So
Right, so
if
do you
I'm getting
recommend
it,
to have this validation
yes,
performed for each of the sublink, or like
yes.
what
So
exactly?
if I am getting the final packet and I own that address, it's one of my addresses. It
Right.
could be anycast. I will respond as success.
So in this case, even if the link breaks, you cannot really detect, correct?
Yes. So it was meant to validate the anycast. So as
Right.
long as it has reached the anycast node, it's all good.
Okay, so that means this validation really doesn't help in the case of if the target FEC is.
The target
Anycast.
FEC is an anycast FEC. So as long as it's delivered, it's
Okay.
successful. Yeah. Ketan Talodikar Cisco. Sorry.
Sure. The other question is, how many other types of the SIDs you have defined so far that this generic TLV is going to?
The idea here would be to define this just one and then cover this
that
and
means,
have procedures around it that can cover all different SID types and is future extendable, because the element that we are going after is the Yang model of the data Yang model of SR. So, and the target here is to really validate the data plane, not carry all information to compare the data plane and consistently check with the control
Sure.
plane.
Yeah, I got that. All I'm asking is, so far, how many of them were defined? And are you going to deprecate all those which were defined so far with this new one?
No. I mean,
if it is not going to duplicate, then
it is for the types that are not defined yet. Let's say for the flex algo is not covered, binding SID is
Sure.
not covered. There are other use cases, but that are not covered. But what is already defined and is RFC is a procedure that will continue to be like this. There's no depreciation here.
no, I mean, if it is going to solve any new types, upcoming new types also, then that means they should solve the existing ones as well, correct? So if that is the case, then you might as well just define this one and say all others you don't even have to use it.
I think that would be working group decision, but I think since there are deployments and all, I don't think
So
that is necessary. But
I mean, if there are some corner cases, then that means those corner cases could arise in the future definitions as well. So that's my
Yeah.
point. It is more like a rhetorical question that
yeah,
if it is going to solve the problem of all the things which are going to coming up, then you might as well keep this as the one and deprecate all of this.
yeah. But I
Just
think
a
there are
suggestion.
two different things here. Like there are additional features that come with the existing fact type, and those features are welcome to use for people. So I think having an option is better than depreciation. I would be more for that. And Shraddha is on the mic. Like there was some discussion with Shraddha as well as going on for the new definitions that are coming, and we're collaborating. So that's why we're not asking for adoption here, but more feedback and working with other folks like Shraddha and Tariq and others.
I totally agree with Sam that there may be corner cases, because since Monday to Thursday, I see that one corner case was brought up on Monday, and I already see one more field getting added here. So we might find more corner cases, and that's what.
Yeah. But I think if you remember, this was presented in Montreal. I had a typo in the slide on Monday. So this was not fair. You're welcome to check Montreal slide. 100%. Please check. 100% check before making his comment. Please check that. Okay.
Tariq from Juniper. Zafar, if you can go back a couple of slides where you will find the FAQ.
This one? Oh, no, here?
Yeah.
Yeah.
So here you're able to put in the SID, the assigner, and the endpoint. So you can validate on the endpoint or the egress, you can validate the SID is valid, the assigner is correct, and we reach the endpoint. But you don't validate what this SID is assigned to. It's missing. And the last statement you said, I'm just capturing what you said. We're doing data plane validation of the label is correct, or actually the label is allocated correctly on the egress. Is allocated correctly or not. So it could be an option that you want to just validate that the label is valid. But I don't think you can deprecate the other effects that are defined. It could be an option. This is what my opinion is. And
I agree with Zarek. I agree. It's not supposed to meant to depreciate anything.
Hello, we got a question from Java. Srish Hari asked if the link between router 7 and router 8 become unidirectional, will the proposal be able to find it?
If the link between R7 and R8 is unidirectional,
yes. Will the proposal be able to find it?
Yes. I don't see anything wrong.
Hi, Greg Mirsky, ZT. So it was very interesting, your response to Tarek. You don't see that this generic FAQ will bring us to the point where we want to deprecate existing SR-related FAQs?
No, I mean, they have different functionality. The existing FAQ are able to do consistency check between the data plane and control plane.
But then why would we call it generic? Because if we have other FAQs that are already being specified, and we introduced a FAQ that I agree it's more flexible and future-proof, why wouldn't we consider, at least consider and discuss, whether just make it truly generic for SR?
Yeah, this is fine, completely fine. And whether we say generic FAQ or label FAQ or find another name, perfectly fine. It could, we can call it label FAQ or SR FAQ or SR generic FAQ. That's all perfectly fine.
Okay, just let's keep it open.
Okay. Yeah. This is for sure SR focused. Thank you.
So, yeah, please, thank you.
hello, my name is Tariq. I'm going to introduce to you segment routing over forwarding adjacency links. So this work is a collaboration between myself, my colleagues, Pavan and Kobe. I'll go over the motivation. I'll give you a little bit of overview. I'm sure you've heard about these FA links in the past and how we can enable segment routing on them and how we can use them. And we'll talk about the next steps. So we wanted to improve scalability in the SR network by creating subpaths, SR subpaths, and the concatenation of these subpaths will give you the end-to-end path. We want to reduce the size of the topology by creating these summarized or compressed links, if you can think of. We want to allow seamless reroute and reoptimization of the subpath that does not impact the end-to-end SR path. And And we want to allow stitching of domains that are running different technologies, signaling technologies like RSVP and NSR, and still create an end-to-end SR path. And we want to be able to customize the topologies that we export from the domain based on certain requirements, based on SLAs and so on. So a little bit about forwarding adjacency links. They were introduced back in RFC 4206. They are point-to-point virtual links. They can appear in IGP, LSDB, or into the TED, Traffic Engineering Database. Such links have the endpoints as the ingress and egress of the FA LSP. The forwarding over the FA LSP is bound to one or more the forwarding over the FA link is bound to one or more FA LSP. The FA LSPs, as I mentioned, they can be signaled using different technologies. It can be SR or RSVP or static LSP for that matter. They can have traffic engineering attributes or parameters, and we can obviously assign them segment routing segments and enable steering over them. In terms of creation and management of such logical FA links, we think they can be configured. The operator can decide they want to configure such an FA link, or a controller can use any northbound interface or a signaling protocol like PSAP, NetConf, gRPC, your favorite, and automatically or dynamically create such links. In terms of the state, if the underlying LSP, or at least one of them, is valid and signaled, then the FA link is operational and ready to accept traffic. FA link key attributes, they can be dynamically derived from the underlying LSPs, or they can be overridden by the operator statically. Now, the FA link can be numbered or unnumbered. For numbered, obviously, we'll be assigning addresses to them, local and remote. For unnumbered, there will be an identifier unique on each endpoint. Typically, depending on the underlying signaling of the LSP, you might be able to gather the remote ID for each side. For example, in RSVP, there is a way to collect it. In SR, there's no such way to identify the remote ID. It's enough for an unnumbered link, unidirectional, to have the local and remote node descriptors as well as the local identifier to pin down the link. Now, there are these symmetrical FA links. Basically, there are links that are co-routed. The LSPs underneath traverse the same path in the forward and reverse. So for this, you need to tie them together. And the remote ID is useful in that matter. So we want to enable segment routing over the FA link so that we can steer traffic on it, build a segment list, and allow an ingress to push traffic over such FA links. The SR architecture did lightly touch on the concept of forwarding adjacency. So, and I did mention that the underlying LSP can be signaled by other techniques than SR, but we can still assign the FA link an adjacency or a SID, a segment. If we do this, an obvious consequence is our segment list will be shorter. Obviously, you can compress the long segment list with shorter segments. This is something desirable. Once we have the FA link, it's treated normally as any other link. It's almost undistinguishable from any physical link in the network. So what type of segments we can assign to an FA link? We have IGP FA links. We can assign an adjacency segment to them, or parallel adjacency segment where you're load balancing equally or unequally. For BGP FA links, such that they're connecting two BGP nodes, speakers, we can assign an adjacency segment that takes us to a specific next hop, BGP next hop, or a a peer node SID. It load balances on multiple possible paths to the same node. And the peer set can actually take you to multiple different next hops in the set. So all these are possible. They're all defined already. We're just reiterating that they are possible. There is an application for this to enter the main. I slightly hinted to it. We can provide the connectivity ingress to egress using such FA links. Once we have that, the end-to-end is just a concatenation of these FA LSPs to provide you the end-to-end path. You can do a full mesh of FA links between the egress and ingress border nodes, or you can do hub and spoke type of FA links and export that. And in fact, you can actually decorate these links with certain tags. And we're thinking of using BGP LS maps for that matter. There is a draft BES enhanced EVPN or VPN, enhanced VPN, not Ethernet VPN. So we're thinking of reusing that or applying it. So in terms of next steps, this currently is an informational draft. I did mention the remote ID is useful to identify the co-routed FA link. We are investigating this at the moment. We might push a new extension, and if that happens, we will transition it to a standards track. This is 0.0 version. We do solicit feedback from the working group. And if you have any question, I'll be happy to answer.
Dhruv, my first question would be, would you compare this to binding SID a little bit?
Indeed. So yes and no. The FA link has an SID associated to it. It can be a binding SID of the underlying SR policy. It can be. But if the underlying is an RSVP LSP, it will be a binding label, or it can be multiple LSPs, in fact. So I didn't mention that, but in the draft they're mentioned. But binding SID is one option, yes.
What I meant was that, can I solve the same problem just by binding SID? Why would I go for this approach? What's the benefit that you are offering? Can you go over
Indeed.
that?
So the idea is that we need to advertise this in BGP-LS as a link and import it into the TED and allow anything that we can do on any BGP-LS advertisement, like tagging on the link NLRI, and make it appear in the TED. Right now, the binding SID by itself, there is no standard way how you push it into the TED. So
I'm kind of lost on that. Anyway, one more question. When would this link go down?
I did mention, well, I can go back, but the idea is let me go back.
It's Peter from Cisco. Hi, Tarek. So if you remember a few years back,
I do remember.
we talked about the forwarding adjacency, and we have somehow concluded. So I just want to make sure you want to advertise this as an IGP link, right?
No, and it's just a link in TED into traffic engineering database. I'm not injecting it. I'm not proposing to inject it in IGP for biasing the steering of IGP. Yeah. It's just a traffic engineering link that will appear in the TE database. Sorry,
So what's the difference then to a regular SRT policy? What's the difference between the regular SRT and forwarding adjacency then?
A link, an FA link, can be supported by one SR policy or a multiple of SR policies. It can have protection or cannot have protection. So there are many cases. I didn't talk about them, Peter, but
so this is not the traditional forwarding adjacency as we know it from the RSVPT.
So the RFC that I mentioned here talks about FA link as a traffic engineering link. I do encourage, I'm not sure if you remember that. It's an old one, Peter, but I referenced it on the slide.
Okay, that's fine. As soon as you not advertise this as a link in the IGP topology, I'm fine.
Yeah.
As soon as you start doing that, you have a trouble.
I agreed. And this is why I answered you. Yeah.
Ketan Talalikar,
Hi,
Cisco. So Tarek, to add to what Dhruv was bringing, I wanted to bring to your attention that we have a draft which is a working group document for exporting such links via BGPLS. The only difference is it's not done as a link NLRI, it's done as a T policy NLRI. But functionally, it can give you the same thing.
So I did come across that. You are advertising the policy and its state and attributes of the policy, candidate path preference. In here, we have a link. It's just a link. It has attributes, and I can do CSPF on it. And I can tag the link with additional attributes or decorate the link if you want.
Yeah.
So,
I would suggest to, if you can think about just as a feedback, to see if you want to add those on the SR policy. This way, the real IGP topology links and these FA links do not get mixed up or can be viewed separately.
All right, good then. Let's talk about that. Sure.
We'll close the line. Robin, can you be brief, please?
Okay. A quick question, Robin Huawei. Is this apply to only SR MPRs or both SRv6 and SMPRs?
So at the current, I did say maybe I mentioned MPLS, but there are plans. Actually, in the draft, I do mention that it can be applicable to SRv6 as well.
So it would be good to discuss whether you will need for the adjacencies or transport paths identified by binding cities. Abstraction is good enough. And we actually published a draft years ago on the integration of IP and optical stuff, which talks about this, has all the signaling needed.
All right. Okay.
Thank you. Next is G. So we have 3 slots related to network slicing. Just to be aware that there is a work going on in T's working group related to network slicing. So I'm assuming that they are going to work on the generic work. And I've heard that yesterday they have a discussion related to the design team. So things are moving in T's working group. And finally, with a bit short of time, so please focus on Spring related stuff rather than generic slides, which are going to be working T's. Thank you.
Okay. Good afternoon, everyone. This is Jiedong from Huawei. I'm going to give some updates about the segment routing-based VPN Plus draft on behalf of the other co-authors. Okay, the background recap, and I will go through it quickly. We have the framework in the TS working group, and the segment routing is one of the candidate technology for this virtual network instantiation, which is part of the overall picture. And in this document, we describe the segment routing-based mechanism to build the virtual networks with required attributes to support the VPN Plus. This document mainly focusing on this segment routing data plane mechanisms and the possible extensions, and it is applicable to both MPRS and SRv6. For the control plane extensions, I think this will be discussed in relevant working groups and with other separate documents. Okay, here are some analysis about the current segment routing. We think segment routing was designed for the south routing, and the seed list is used to specify the nodes and links should be the traffic goes through along the path. And in current status, the services will share the same group of seeds, and currently they cannot differentiate the traffic using the seeds. But the question is, with segment routing, can we create customized virtual networks? The second question is segment routing. Currently, it does not take the resource reservation into the consideration, so that the seeds just steer the traffic along the path. It's a link level granularity traffic steering, and basically it can rely on the diffserv QoS for the traffic differentiation. It may be good enough for some existing services, but we think there are gaps and the challenges for them services like the 5G critical applications. So the other question is how can we achieve the guaranteed or more predictable SLA with segment routing? Okay, here is the proposal in this draft. Basically, we introduce the topology and resource information into the seed semantics. We can use the seeds to identify the topology on the data plane. So we can use different seeds to identify the same node or link in the different network topologies. In addition, we can also use the seeds to represent a subset of network resource allocated to a particular virtual network or network slice. We see the seeds is an abstraction of the different mechanisms in the underlay to provide you the guaranteed resource isolation and the guaranteed performance. So it's a good abstraction of different mechanisms in the underlay. And with this mechanism, we can use seeds, different group of seeds to create different network slices or virtual networks. And with the seed list in different virtual networks, the traffic will go through the isolated topology with the isolated resource so that we can keep all the traffic in different network slices separated and not interfere each other. Okay, here is a similar mechanism for SRv6. I think for SRv6, we need to use different locators to identify the different network topologies and on the same node or links. And the seeds, SRv6 seeds, basically it will inherit the topology identification from the locator. And in addition, we can also add this resource semantics to the locator and seeds to represent the subset of resource in the underlay. Here are the updates since last presentation in IETF. We add new co-authors and updated affiliations of some authors. We also add references to the narrow slicing definition in 3GPP and also in the VPN Plus framework. On this one, we also clarify that the seeds can identify the topology and may represent the associated resource so that we provide a unified data plane mechanism for both soft and hard isolation. We also soft received the review comments, and there are some editorial changes to make it more readable and updates to the reference. Okay, for the next steps, I think we received some further comments, which we can solve them in the next version. And we think the framework has been adopted in TIS and it gets mature towards the working group last call. And so for this document, we already work on this since early 2018. And the contents of this draft is also getting stable. We already see many interest from operators to have a segment routing-based network slicing solution. So we have raised this working group adoption request to the mailing list and would like to hear the opinions from the working group. Okay.
So who has read the draft? 15, 20. Who believe it's a good start for a working document? About the same. Who believe it's not a good start for a working document? 1 person, 2 person. Okay, so we there has been a new design team in TIS related to network slicing. So I think it would be good to wait a bit on the outcome of the design team because I expect TIS to, in general, define the network slicing subject, and then we can work on what Spring has or does not have. To fulfill that network slicings.
Yeah, I think this can be relatively decoupled from the work in the design team because we already have the framework of the VPN Plus in the TIS, and we think this is a solution for VPN Plus, and one of the use cases is network slicing. So this is based on this current status. Maybe we can no need to rely on this. Progress in the design team.
I also have
my personal.
Yes, I also have some comments on the draft, starting with the name. So plus is a bit of marketing, so it could be useful to know what is added. So my guess is some network partitioning. VPN, this is not really the scope of the working group, and I'm not sure your draft is about VPNs. So maybe the introduction on the title are not the best fit.
Okay.
So there are different terms used. I'm not sure they mean the same thing or not, such as network slicing, VPN, virtual network. As a consequence, it's not very clear. For example, it's not very clear if you're asking for VPN states in the core.
No VPN states.
Yes, but
Yeah,
given the terminology is not clear.
Yeah, maybe we can clarify this in the framework. The VPN Plus is the term of the framework. It's the integration of the overlay VPN and underlay network. So we call it the VPN Plus, but it's not either overlay or underlay. It's both.
And do you think it could be a better phrase that's a way to partition network resources in Spring or segment routing networks to avoid the term VPN?
We will consider whether
Okay.
we have a better name.
Thank you. Jeff?
So as a member of design team, it's not the intention to define technology as such. The focus is northbound APIs and programmatic interface between higher level business logic and underlying control architecture and data models associated with it. So we are not going to work on this specifically. And since as organizations, SDO, we are trying to align on meaning of transport or network slice, would be actually good to kind of express same meaning when we use same words. And please think about it. You're part of design team as well.
Yeah.
So we work together, right? Not against each other.
Right. Yeah. I will also contribute to the design team. I think this work can also, if this is outside the scope of the design team, we can work on it in some place else.
Funking from China Mobile. Now 5G is about to enter commercial stage in China Mobile. We have verified many use cases of network slicing, such as the smart grid, the HD video radio, and the mobile surgery, and so on. Good results have been achieved. There are many services asking for network slicing. This draft provides the SR-based data plan. I think it is a good idea. Thank you.
I'll cut the line. Adrian, are you part of the line or no? Okay. Right.
Hi, I'm Zan from ZTE. I agree with Jeff. I'm a member of the SLAS design team. This is out of the scope of the design team. And we have another technology about the SR. Later, we will do the presentation. Compare with, yes, I have another three questions. The first is compare with your architecture draft. I think there is no more new technology. I don't know what's your meaning of this draft as a standard truck draft. And the second question is for IGP extensions. I think this is an opening questions, and it is also to your draft has some references with your individual control plane draft, but I think it is an open questions. We should do further discussion, and we also have an extension of control plane draft. So I'm not think it is good.
Okay.
The second question is for select resources. We first introduced select ID for select resource management, and our solution can differentiate the, for example, L2 link and L3 interface. In your draft, how to compute SRB or SRT path according to select ID combined with other criteria. I think this is not very clear in your draft, and in our draft we have described it.
Okay.
Maybe you could reply on the list. Yes, please.
Yeah, just I want to maybe emphasize that this is a draft about a segment routing data plane. The control plane belongs to other separate documents. And,
Yes,
and this
I
is,
know.
we want to show the extension to the semantics of the seed. because previously it's just to identify the node or link, but we give the finer granularity of the resources on the link and all the virtual topology on the node. So this is the extension to the data plane.
But in your draft, you referred your control plane draft.
Can we move that to the list, please?
Okay.
Could you send your comment to the list, please?
Okay, yeah.
But I agree, we need a better structure of the document in related to network slicing. Robin, the line has been cut. Craig? No. Okay.
Rakesh from Cisco Systems. So I'm also part of the network slice design team in TEAS. And what's in scope is the requirements as well as the framework for network slicing. So we need to make some progress. And I think G is also part of the network slice, the same design team as well. So G knows very well that we need to make progress on the requirements as well as the framework. So I think we agree with Bruno that let's wait a little bit more to solidify those aspects.
Greg Mersky, CT. The paradigm of network slicing includes several models for resource sharing. My understanding that VPN Plus concentrates only on a subset of these use cases and includes the isolated resources. So there are another set of use cases where resources are shared. So I would encourage to work on the model that includes all use cases, not just one addressed in VPN Plus.
Yeah, I think here we have one clarification that this data plane can provide either soft or hard isolation, which means the resource can be either shared or isolated. But we can use a unified data plane by the control plane. Information would be different for different requirement.
Well, again, it's not that simple, and I think that resources are of different flavors. So we're not only talking about connectivity resources, there are other resources, and we need a way to express them, especially if you want to have combine of hard and soft isolation.
Okay, maybe we can discuss more.
Yeah. Okay. The line has been cut as well. We are late. Zafar. So we need to discuss on the list, but we definitely need to sync with TEAS working group. You need to refine the scope of your draft, make the title on abstract and introduction in line with the scope. So if it's about VPN, maybe it's not for Spring. If it's not about VPN, maybe rephrase it at partitioning network resources. I have some other comments, but I'll send it on the list.
Okay, thank you. Thanks, Bruno. Okay.
We are a bit late, so if you can gain some time, it will be even better. Excellent, thank you.
Okay, I try to do it in 5 minutes. So the objective of this draft is to start by outlining the building block for slicing that already exists in SR network, and then see the gaps and how we can address those gaps. So this elaborates what are the building blocks and how we can use it for network slicing. So here's a list, initial list. So we have support for SR policies with or without flex algo. Then we have notion of flex algo for slicing. We also have notion of doing TILFA within a slice, underlay slice. We have notion of carrying various VPN services that is also provides separation among the customers. And then support for service programming, ONMPM, the QoS aspects, and orchestration. So these are some of the building blocks. I'm short on time, so I'll go fast. So let's think of SR policy first. So SR policy is a way that we can take a common network and can steer traffic that will satisfy a certain requirement, for example, low latency or disjointness. We have ability to do path calculation for different optimization criteria and ability to isolate certain type of path from the other. We have support for the ODN and support for automatic steering into the SR policy. And SR policies can span multiple domains, and this is something which has been widely deployed in segment routing network. Then we have notion of flexible algorithms which associate intent to a prefix SID. And it allows IGP to compute path, constrained path based on the intent. So let's say low latency, flex algo low latency slide. And then IGP is able to run CSPF to satisfy the intent and it is a way to create provision network slice with different intent. Then we have notion of TILFA and micro avoidance. But the beauty here is that when we do TILFA for flexible algo, the backup path only uses the resources that belongs to that algo. So primary and backup both uses individual slice of the network. Then we have ability to carry various different type of SR VPN services like L3 VPN, VPWS, VPLS, and EVPN services that provide various level of separation of services from a customer point of view, or different customers can have different type of service differentiation or service isolation from a common underlay. Notion of service programming allows customers to do traffic engineering or intent-based routing, not only through topological segments, but also through programmable service programming like network appliances and support for the NFVs and service function chaining along with topological segment bound to a specific slice.
Zavar?
Yeah.
Actually, you exhausted your 5 minutes.
Okay.
But I think your first slide was very interesting. It's a good summary of all the tools we have in Spring to fulfill some requirement from network slicing.
Yeah.
Maybe one thing which is missing is what is missing actually in Spring. What is missing? What tool is missing in Spring, or what tools are missing in Spring to fulfill the requirements? So again, we may need to wait for all the feedbacks from this design team, but I think it's a good start to see what we have.
Okay, thank you.
But it's really also interesting to see what we don't have. On one part could be a segregation of resources within the network and SPRG. Jeff?
Very similar to previous comment. It's a great overview of what segment routing can do, but it's neither correct nor complete definition of what network slice is. So use terminology correctly. It could be used as a subset of what we are trying to do with network slicing, but this is not the network slicing, and don't call it this way. It's really wrong.
So please send comments, and yeah, for sure.
Okay,
yeah.
Please send comment on the list.
Comments from like Zhenqiang Li from China Mobile. Please add resource segment presented by Jedong to the building blocks. Thanks.
Yeah, so you're using time out of the next presentation to say go to the next presentation. But okay, so we'll move to the next presentation. Please send the comment on the list.
Thank you.
Thank you. So next, please. Please make it short. We already had 2 presentations on network slices, so please summarize on what is the big difference of your proposal. Hopefully, if you can make it in 4 minutes, it's even better. Thank you.
Hi, everybody. I'm Feng Jin from China Mobile. Now I will talk about packet network slicing using segment routing. The end-to-end network slicing defined by 3GPP, include the range slice, transport slice, and call slice. Now I will focus on the transport network slice. There are 5 major requirements. The first one is the dedicated virtual networks. The second one is the end-to-end slicing. The third one is the unified NSI. The fourth is the traffic engineering. The last one is last to as well as the last link resource partition. There are also some existing identifiers, but they could not meet all of the above requirements. So I will reduce the new slice-based identifiers called administrative instance identifier, or AII for short. AII is the implicit virtual network identification. It could be used as a transport network slice identifier. It indicates the topology, computing, and storage resources of the dedicated virtual network. AI is the identifier of the dedicated virtual network for the slice. It could support the end-to-end slicing. It could also identify the unified NSR. AI is one of the constraint criteria of the color template, and the color template with AI provides a more flexible control. It is independent of the existing domain pattern. In order to distinguish the forwarding behavior, the prefix will be allocated to AII, so there is no modification to the forwarding plan. Here is the example of this solution. The controller collects the resource information with the AI while BPLS, and establishes the corresponding SR virtual network, and calculate the path according to the color with the AII. There is 2 topologies, red and black. And also AI is could be as a set of transport network slice resource identifiers. This solution supports both soft and hard solution. For the last 3 interface slice solution in IGP domain, each enabled or enabled last 3 link could be configured with the AI information and synchronized among the IGP neighbors. The IGP link state database could contain last 3 links with the AI to support the TE path computation, taking into account of the AI criteria. For the lane 2 interface slice isolation, each line 2 number link of line 3 parent link could be configured with the AII and the adjacent set. The line 2 number link could be a flex E tunnel or Ethernet tunnel and other such as other interface type. In the control plane, the routing protocol packet following the last 3 links will select the line 2 number link with the highest priority. At the same time, in the forwarding plan, data packet belong to the specific virtual network will pass along the line 2 number link with the specific AI values. The path computation based on the link state database will inspect the detailed line-to-number link of line 3 adjacent to select the expected link results.
Okay, excuse me. We won't have time to go into the details, but
okay.
basically
Okay.
the same comments.
Okay.
We have to start with the result of the TEAS working group design team to see what we have to do in general for network slices. And then we need to focus on what we have and what we don't have for Spring.
I'm not in the design team.
Yeah.
I'm not in the design team. I will join the design team.
Okay, you're part of the design team, which is good, but we may need to wait for the result of the design team to know what we have to do. And then we can start identifying what we have in Spring, mostly in data plane, and what we don't have. And then we can work on what we don't have.
Maybe I will apply the client, and after the meeting, after the line meeting, I will design team and do the contributions.
Yes, but actually the meeting is already over time. No, you won't be quick. We're already over time. So again, most of network slice work is to be started in the design team of this working group. And then we can work on what is missing in the Spring. Thank you. If you have comments, please send us the list. I'm very sorry. I think we are finished. I'm very sorry for the next slide. Next presentation. The slides are much improved. There was already a discussion in the MPS working group, so it has been presented. But the draft needs now to be aligned with the slides because I don't think they are aligned. So maybe there is work to be done on the draft following the discussion during this meeting. And well, it's finished. It's finished. So thank you for your time, and see you in Vancouver. So again, Vancouver.
哎，你得比对这一下，你得比对这。